circles. We're going to look now at the topic of circles on your course. And circles are very interesting. They're unique on your program for one particular reason. And that is the equation of a circle, well, has x squared plus y squared in it. This is just the cover sheet. Sometimes x minus 2 by y minus 3 and all that equal to something. Or it's got x minus by x plus. But the most interesting point is that there's a y squared or an x squared. And if y squared is equal to something, let's say it's equal to 9, then y would be equal to, well, you'd square root it. And if you square rooted it, you'd get y was equal to plus or minus 3. And this is the only part of your course where the function here, for a given x value, say 2 or 3, has a y value here and a y value here. Y values in two different places. If you think about the straight line y is equal to 4x plus 1, that just had a single value of y for every single value of x. Y is equal to x squared plus 2x plus 8. That only had one value for any given value of x. It was a quadratic. But this thing here wraps around itself because it has both x squareds in it, like the quadratic, but also y squareds in it. So that's what this topic is going to be about. It's the only part of your course where basically an x value can have two y values. So the general equation of a circle, there are two types on your program. The first one has its origin at 0, 0. That's the most straightforward one. So we look at that and we talk about x squared plus y squared is r squared. That's the generic formula. Or an example would be x squared plus y squared is 5 squared. So here's a straightforward example of x squared plus y squared is 5 squared. There's no other terms in x, no other terms in y, no terms in x, y, just the square, and a number. That means that it's at 0, 0. The 5 squared means that the r squared is 5 squared, r is 5. The radius is 5. So every point on this circumference is 5 away. So if I look at this point 3, 4, 3 and 4, from Pythagoras I can get 3 squared plus 4 squared is 5 squared. But equally I could have gone to this point here and gone minus 4 back, and here 3 up. Again, because it's distance, I would have said the modulus, 4 squared and 3 squared is 5 squared. So the whole thing is prescribed or by just this one circle. If you held a string in the middle and somebody ran around or whatever, they'd always be the same distance from the center. A more generic circle is one that has its center elsewhere, not at 0, 0. So the full formula for that is x minus h squared plus y minus k squared is r squared. Both of these are in your formula tables. And here's a specific instance. It's x minus 2 by y minus 4 is 5 squared. And that's a giveaway. The center is at hk when you have a minus h minus k. So if you have a minus 2 minus 4, the center here is at 2, 4. So plus 2 plus 4 with a minus 2 minus 4. Had it been x plus 2 here, the center would have been at x minus 2. So all it is, it's again a very similar looking shape. Obviously it's a circle, but it's not anchored around the center at 0, 0. It has its center at 2, 4. And that's its equation. X minus 2 squared plus y minus 4 squared equals 5 squared. It's not the only way to present the circle like that. You could, from algebra, decide to expand each of those. And x minus 2 squared, you could have said is x minus 2 times x minus 2, the FOIL method. And you would have multiplied it out to get x squared minus 2x minus 2x plus 4, or added them all together. And when you rearranged, you ended up with bits on the way, but finally you ended up with this. X squared plus y squared minus 4x minus 8y is 5. That's not a new equation. It's just the rearranging of this equation. It's exactly the same. It's an expansion or a simplification or an alternative presentation or whatever of it. If we were to do that for the generic hk and expand it out, we'd get h's and k's in there, a whole load of stuff in there, and we get x squared plus y squared, as before, minus 2hx minus 2ky, but on the right-hand side, all of this stuff, r squared minus h squared minus k squared. All of these equations are in your formula table, and you can use them. So what might you be asked to do? Well, the syllabus specifies that you have to be able to draw a circle. That means you have to bring in a compass as well. So here we've got a center at 0, 0, and the radius is 5. So what we would do is we would go to 0, 0, wherever that might be here. We might go out 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we will draw some circle like that. Now we will do it with a compass, and we'll do it with the compass later. So what I'm going to do is I'm going to draw all the various constructs and shapes in the construction side. We won't take them in the circle side here, but we will draw perfect circles. And all of the formations and constructions you're meant to do, we're going to record separately, so you can see that as well. But at the moment, we're looking at here, just you don't have to draw a circle. Okay. So we get x squared plus y squared is 25. X squared is 25. How would we solve for y? Well, we've done a lot of rearranging of formulae. Basically, we're saying if x squared plus y squared is 25, what's y? Well, it's really standard manipulation of algebraic equations. We're saying that's the bit I'm interested in. So you're saying that x squared plus y squared is 5, but my focus of attention is y. I would like y to be on the left-hand side of the equation, but not anything else. So I'm going to start here by saying I'm going to get rid of the x squared. So x squared plus y squared is 5. I'm going to take x squareds from both sides. So they're still holding those equations, but that's going to cancel. So I now have y squared is equal to 5 minus x squared. That's not bad. I'm close. I've got y on the left-hand side, nothing else, but it's a y squared. So to get rid of a y squared, to get rid of a square, the paired operation is the square root. And again, to do that, I can just cancel that, but that's going to give me y equals, because the square of a square root or the square root of a square disappear, gives me 5 minus x squared. And that's my expression for y. Now, in this case, because it's the circle, when I get the square root, I'm actually going to be interested in the plus or minus value, because the square root of 4 is both 2 and minus 2. So you can see there in the material that the y then turns out to be the square root of 5 squared minus x squared. So, for example, if somebody said to you, I want to find a point on this circle, how would I do that? I want to draw a point. How do I figure out what the points are? I know that it's at 0, 0. That's one. That's the center. And 1, 2, 3, 4, 5. I know that 5, 0 is on it. I know that 1, 2, 3, 4, 5, 0 minus 5 is on it. I know that 0, 5 is on it. And I know that minus 5, 0 is on it. But could I get a series of intervening points that would help me draw this a bit easier? In other words, what's the value when x is equal to 3? What's the value of y then? Well, the way you do it is you'd go back to the formula that we've just picked up. And I think the formula said y is equal to the square root of 5 squared minus x squared. So if y is equal to the square root of 5 squared minus x squared, well, we've done a million of these. We just say, what's the value when x is equal to 0? When x is 0, y is equal to 5 squared minus nothing squared, which is 5 squared, which is 5. For the moment, we'll call that plus or minus 5. When x is 5, y is equal to 5 squared minus 5 squared, which is 0, which is 0. That's giving us the points x is always first, 0, 5, 0, minus 5. This is giving us x is 5, 0. If we had put in x equals minus 5, we'd get the same. We'd get square root of 0, and we get minus 5, 0. Okay? But what about the intervening points? What about x equals 3? Well, if x is 3, we'd say y is equal to the square root of 5 squared minus 3 squared. That's the square root of 25 minus 9. That's the square root of 16. And the square root of 16 is plus or minus 4. So now we're saying when x is 3, the values are 3, 4, or 3 minus 4. Similarly, if we had said let x equals 4, or minus 4, we'd say y is equal to the square root of 5 squared minus minus 4 squared. That's 5 by 5 is 25. Minus 4 by minus 4 is 16. That's the square root of 9, and the square root of 9 is plus or minus 3. So the points here would be minus 4, 3, or minus 4, minus 3. So really what I'm saying is that the 3, 4, and minus 4 would give us the 3, 4, and minus 4. The 4 here, minus 4 would give it plus or minus 3. Minus 4 would be 3, 3. If I filled in more, I'd get this point here. And now you can see that maybe it's getting a little bit neater now. Now, it'll be an awful lot better if I did it with a compass. But because I've taken more points now than just the first 4, you can see it's pretty close. X squared plus y squared is equal to 5 squared. And that's how I would get those points. So what you've got to do then to draw a circle is, if you're given an equation, is try an x value, try a y value. You'll know that if x is 0, you'll find y quick enough. It's 5 and plus or minus. If y is 0, x will be there. And then pick a point in between. And if you take enough of them, you'll be able to draw it. They want you to do it with a compass, and there's time for that, and that's the way the question is phrased. You'll do it that way. So that's how I did the Pythagoras. I have a center at 2, 4, a point at 5, 8. So this is the next type of question. Exactly the same, but it's not at 0, 0. They say the radius is the length between the two. Will you actually draw that circle? So what they're saying is the center is at 2, 4 now. The point is 5, 8. So 2, 4 and 5, 8. So you go out to 2, 4 and you say 1, 2, 1, 2, 3, 4. We mightn't do it quite like that. We'll use the paper this way. It might be easier. Eight, that's great. 2, 4 is here, 1, 2, 1, 2, 3, 4, and 5, 8 is 5, and then another 4 would be 1, 2, 3, 4 here. So what we're saying is this is the point 2, 4, and this is the point 5, 8. They want you now to construct a circle, standing here with the string going all the way around. Now, you would have your compass. But what you might do is you might say, well, what's the length? This is the radius r. This is 3 more out, because the difference between 5, 4 and 2, 4 is 3. 5, 4 and 5, 8, the difference is 4. 3 squared plus 4 squared is 5 in the standard Pythagoras. So we know it's 5. We could also say, well, if the radius is 5, then let's try a few more points or whatever. And we can plug those in. We could say, we know that the equation, if its center is minus 2, is x minus 2 squared plus y minus 4 squared is now 5 squared, because we've identified the radius. And we know the center is at 2, 4. So we actually have the full equation now. X minus 2 squared plus y minus 4 squared is 5 squared. So we could try, when y is 0, what's x? When x is 0, what's y? And we could go around forever doing that. And eventually we'll get some sort of circle that will in some way show that something's right. Okay? The more points, the more accurate it'll be. That's our equation of the circle. The next step, though, is they ask you this question. They say, there's a circle, it's got a center, it's got a radius. Is this other given point inside, outside, or on the circle? So here we're looking at points on, inside, and outside the circle. I've chosen the circle again at 2, 4. It's got 5, 8 there, so it's got the standard 5 squared. It's the same Pythagoras that we've been using fairly constantly, the 3 and the 4. And we're asking ourselves, is this point 2, 2 here in or outside the circle? Is the point minus 6, 2 inside or outside the circle? And what's this point here, 6, 1? Well, visually it looks like that's clearly inside, that's outside, and that's on it. But how would we work it out? Well, we work it out by one simple rule. If you're here and you work out the shortest distance to a point, like that point there, or the shortest distance this way, or the shortest distance in any with using the line to get to the point you're looking for. So you might say, okay, what's the shortest? The shortest distance between 2 points is the straight line. So that's one of them. This is another. And here's another. Now, it's only when the lines here are exactly the same as this length that it's actually on the circle. So we're now going to find the distance between them. Now, from another topic, you might use the equations in the line. This might be x1, y1, and this could be x2, y2, to work out the distance between the length of a line segment. Or you could say, let's just do it from the graph here. It looks like I'm going from 2, 4 to 6, 1. If I go from 2, 4 to 6, 1, 2, 4 is 2, 4, to 6, 1. Well, what's happening to me? Well, I'm going this distance, okay. But on the horizontal and the vertical, I can say, well, this distance here from 2 to 6 is a distance of 4. And this distance here from the 4 to the 1, because this is the point 2, 1, is 3. So that's 3, and that's 4. This must be 5. So from 2, 4 to 6, 1, it looks like I've got 5. What about 2, 4 to 2, 2? Same idea again. 2, 4, I could do it visually. 2, 4. This is 2. 2, 4 is here. And this time I want to go to the point 2, 2. Well, this is only moving in one direction. I only have to move south. And the distance between 2, 4 and 2, 2 is 2. And 2 isn't far enough away from the center to be the radius. And equally, if I did the third one, the third point I think is minus 6, minus 2. So if I look for maybe this paper here, So I'm looking at the point 2, 4, and minus 6, 2. So 2, 4 is 1, 2, 1, 2, 3, 4. And minus 6, 2. 2 is here. And I say, what length is that? Again, I can show the lengths here. If this is minus 6, 2, and this therefore would be 2, 2. The drop in length here would be 2, and from 2 to minus 6, that's 2 east, that's 6 west, so that's 2 plus the 6, that's 8. So this thing here would be 8 squared plus 2 squared. I don't know what 8 squared plus 2 squared is. That's 64, that's 4. It's the square root of 68. Don't know, I have to work it out. It's an awful lot bigger than 5 because the square root of 25 is 5. And 68 is bigger than 25. So this is outside the circle. That's for sure. And that's how I would do that. So I can do that using Pythagoras. I can do it by doing it visually. Or I can just do the standard, absolutely standard, from the line section, x1 minus x2 squared plus y1 minus y2 squared, all square rooted. That's exactly what's going on there. So for the first point, 6, 1, I found that it was on the circle. For point minus 6, 2 to 2, 4, I found it was the square root of 68, which was 8.24, greater than 5 outside the circle, and the very one, 2, 2 and 2, 4, only 2 apart, much smaller than 5, that's inside the circle. So that's that section done. We now look at the next topic in circles, and we talk about circles and lines. Where we're really saying is that the circle now is going to intersect, it's going to cut across another line. Now, this could be a picture of it. You've got a circle, and there's a clear line it cuts through, and that's the x-axis. It cuts through the y-axis indeed as well here. So we could show that by saying, well, here's the y-axis. Or we can show it and say, here's the x-axis. But it could also be a line like that, or that, or that, or any line. You could be asked to intersect that line with anything. And you'd be well able to do it because in graphs and functions we would have covered much of that. But let's look at the intersection of the circle and the line. Well, what is it? Really what we're saying is that the circle itself has an equation. And the equation is given here. X minus 2 squared plus y minus 4 squared is 5 squared. That's only one equation because there's only one equals there. So you've only got one line with an equals and you have two variables, x and y. And the only way you can solve two variables is if you've got two equations. It can't be done otherwise. So you need another something with an equals in it with x and y, or one of them in there. So how do we do that? Well, which line are we talking about? Well, let's say we're talking about this line here. Well, that's the x-axis, we call it. But the x-axis has an equation because the x value is always the y value is always 0. 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. The xy part is always showing a y value of 0. In other words, the second equation we have is y is 0. So we have one equation, two equations, two equals, two variables, x's and y's, we can solve the question. So how do we do that? Well, the first equation is y equals 0, and the second one is that. And if we're making them equal, we're saying that they're equal at the point, this red one and this one, the 2 points of intersection, where this point is on both the first equation, which is the circle, and the second, which is the line. So we join the two together. So really what we're saying is that x minus 2 squared plus y minus 4 squared is 25. But also y is 0. And if y is 0, you can put it in here. So the equation now becomes x minus 2, well you can see it here, developing, that x minus 2, the y has become 0. So x minus 2 plus 0 minus 4 squared is 25. Multiplying that in, the x squared is the same. Minus 4 squared is 16, is 25. So now we have x minus 2 squared minus or plus 16 is 25. Now we can make this, we can solve this in a few ways actually. One of the ways you do this is you take the 16 over and you say x minus 2 squared is equal to 25 minus 16. X minus 2 squared is 9. And if you're slick on this, you can say x minus 2 squared is 3 squared. And now you can say x minus 2 is 3, or x minus 2 is minus 3, because we'll be getting the square root if we do that. So x on this one would say x is 3 plus 2. Here we'd say it's minus 3 plus 2. This would give us an x of 5. This would give us an x of minus 1. So it looks like the x values are 5 and minus 1. And that's 5 naught there. And that's minus 1. And that's one way we could do it. But we may not have spotted that slick way of doing that. So we may have been sort of going through it at a slightly slower way, but more reliably. When we were doing that, we would have had x minus 2 squared. Let's go back to where we were. Plus 16 equals 25. So plus 16 is 25. X minus 2 squared is equal to 25 minus 16, which is 9. Now let's expand this out. X minus 2 times x minus 2 is 9. Do the FOIL method, multiply it across and all that stuff. So we say x squared, x by x, minus 2x plus 4 is 9. X squared minus 4x plus 4 is 9. X squared minus 4x, taking the 9 across, plus 4 minus 9 is 0. X squared minus 4x minus 5 is 0. So now what we have is we broke it down into a quadratic where we've got x squared minus 4x minus 5 is 0. And how do we solve that? Well, you can solve that through algebra, through the minus b, so it's always reliable. On this occasion, we'll just look and see if there are factors. The factors of x squared are x and x. And the factors of 5 are 5 and 1. Now, it's a minus 5, so it must be minus 5 and plus 1, or minus 1 and plus 5. But I want a minus 4 overall, so I'm going to go with the minus 5 and the plus 1. So x minus 5 times x plus 1. If I do the FOIL method on that, I should get x squared minus, or plus x minus 5x minus 5, x squared minus 4x minus 5. Well, that tells me that those factors are right. That either x minus 5 is 0 and x plus 1 is 0. Now, joining the factors and the roots, if x minus 5 is 0, then x minus 5 plus 5 is 0 plus 5, by adding in 5 on both sides. They cancel, and we get x is 5. Similarly, if x plus 1 is nothing, we can say x plus 1 minus 1 is nothing minus 1 to get rid of this 1. They cancel, x is equal to minus 1. These are now the roots. And that would suggest that at x equals minus 1 and x equal to plus 5, if I go looking for it, somewhere if I can find the graph, if it was there, it's here. When x is equal to plus 5, which is here, plus 5, and here minus 1, that's the value. And that just gives me the x value. How do I find the y value? Well, the y value is always 0, but if I wanted to use the other formula here, x minus 2 squared plus y minus 4 squared is 5 squared. And I'm saying that the first value I'm going to try is x is 5. Well, when x is 5, this becomes 5 minus 2 squared plus y minus 4 squared is 5 squared. But y, I think we were told was, what were we told there? Oh, we had an equation for y. What was our y equation? Had we got it expressed? How would we resolve this? Let's say we wanted to find out the y. So let's go through that again. We have x minus 2 squared plus y minus 4 squared is equal to 5 squared. If I knew x and I wanted to find y, how would I do it? Well, our plan has always been to put y on the one side. So y minus 4 squared is equal to 5 squared minus x minus 2 squared. Taking the square root, I get y minus 4 is equal to the square root of 5 squared minus x minus 2 squared. And I would get y is equal to 5 squared minus x minus 2 squared plus 4. So if I did want to find the points, I say, what's the value when x is 5? When x is 5, y is equal to 5 squared minus 5 minus 2 is 3, so that would be 3 squared, plus 4. Plus or minus this now. So if I take plus or minus that, what's the plus or minus that? 5 squared minus 3 squared? 25 minus 9? 16? One of those answers is going to be minus 4 plus 4. That's going to give me a naught. If I try x is equal to minus 1, I get y is equal to plus or minus here, 5 squared minus x minus 1 squared. Minus 1 minus 2 will be my 3 squared again. 5 squared minus 3 squared will give me my 16. I'll end up with minus 4 plus 4 is 0. I needn't have gone through all of that grief because I did know that the y value was 0. But I'm just saying that you can always go back into an equation and you can say, if I have to get y on this side, I do it. I know the x, I plug in the values, and I'm done. Now, this section here deals with how they try to hide a question from you in the exam. What they've done in the first section is they've given you the center and they've given you a radius and therefore you can draw it. Or they've given you the equation of the circle and you can draw it by plugging in numbers. And they say, how can we conceal this so that not everybody gets 100% of the marks? This is the first trick they do. They say, here is, you are given the diameter of a circle. So leave that with you. How do you construct it? The only things you're given are 1, 1 and 5, 7. Over to you. This is a Sudoku type problem. How do you get back to the center and the radius the way we used to do it? You're given 2 points. So take a minute or two on that and write down how you're going to do it. Okay, returning to this question then. The diameter given the end points. Well, if you're given 2 points here, and they're the diameter apart, is there any way we could be able to identify what the center is? You think so? How do you get the center of a diameter like that? Is that the equation for the midpoint of a line segment or something? Is it? Because halfway across the diameter is the center, isn't it? So if we look at it and say minus 1, and 5, 7, if we started off and just consider the east direction, east-west direction for the moment, okay? We start off at minus 1, or we start off at 1 west, and we go to 7 east. That's 1 plus 7, 8 steps. What's half of 8? 4. And what's 4 steps east of minus 1? 3. So that looks to me as if it might be 3, is it? So it looks like it's 3. Minus 1, 5, 7. Sorry. 5, wasn't it? I'll do that again. That's a pity. I must get another copy of that. So now let's return now to the diameter question. You've got a point at minus 1, 1 and a point at 5, 7. So minus 1, 1 is here, minus 1, minus 1. And a point at 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7. This is the point 5, 7. So if we were to consider this in terms of east and west, or positive and negative, we're starting here at 1, 1, and we're going to 5, 7. And we're told, the only thing we're told, we're not drawing a graph of this circle, we're told that that's the diameter. Well, if that's the diameter, what's halfway between? Well, let's take the east side. This is minus 1, or 1 west, to 5. This is the point here. 5 minus 1. So in going from minus 1 to 5, I'm going to 1 plus 5. I'm taking 6 steps. Half of 6 is 3. So 3 steps would be 1 to bring to normal, and then 2 here would bring me to the point 2 east. So that would seem to be where I'd want to end up on the east side, at halfway between here and here. So if I cut the direction here, find it then. Going north, I was minus 1. I was 1 south, and I'm going to 7 north. So that's 1 plus 7, a total of 8. Half of 8 is 4. 4 from minus 1 is 1, 2, 3, 4. It will bring me here. So that will bring me to 3. So the point, I think, now is 5, 3. And if I cut across at that point there and find where they intersect, I get this midpoint, which is 2, 3. And that's the halfway point between those two. It's minus 1, added to 5, 7, giving a total of 4, 6, divided by 2, 2, 3. That's my midpoint. Most likely you would have done that by going to the formulae tables and saying that the average is, the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. Given that you knew x1, y1, you knew x2, y2. You knew that x1, y1 was the first one, and x2, y2 was up here. You knew that x1, y1 was minus 1, minus 1. This was 5, 7. And by plugging in the numbers here, you got minus 1 plus 5 over 2, comma, minus 1 plus 7 over 2. That's 4 over 2, comma, 6 over 2, or 2, 3. So that's how you found it. Now, if you did find the center of the circle then, and you found it was at 2, 3, which is here, 2, 3, and that's the circle, That gives you the center. How would you find the radius? What's the radius? It's the distance from 2, 3 to either of those points, isn't it? So how far is 2, 3 from 5, 7? Well, again, using the information on the line, you'd say 2, 3 is here, and 5, 7 is here. Two, 3, 5, 7. How do I work out that length now that it's just the radius? Well, I can say how far out are we going in one direction and how far in the other direction. Because we're talking about the Cartesian system, we're talking about 90 degrees. So this is the point 5, 3. So again, 2, 3 to 5, 3, that's a distance of 3. 5, 3 to 5, 7, that's a distance of 4. 3 squared plus 4 squared is 5 squared. That's the 5. How would we have done it? We probably would have said we now have a point x1, y1. We have a point x2, y2. And we would have used the formula for the length. And we would have said the length is x1 minus x2 squared plus y1 minus y2 squared, square rooted. Where x1, y1 was given as 2, 3. x2, y2 was given as 5, 7. And we just took the time in our own space, having written this down and written this down, to transcribe one into the other. So we'd say x1 is 2, so that's going to be 2 minus x2 is 5, plus y is 3 minus 7 squared. 2 minus 5 is minus 3. Minus 3 by minus 3 is 9. 3 minus 7 is minus 4. Minus 4 squared is 16. That's the square root of 25. That's 5. And while you might have plus or minus 5 on it, it's always going to be positive because we're looking at a distance. So it's the absolute value. It's 5. Now, where are we? Well, now we know the midpoint, or the center, going back to the diameter of this question, we know that the center is at 2, 3, and the radius is 5. That's the same old question as before. Okay? So this is how it's done. The diameter given the endpoints, you find the midpoint. The radius, you find the distance from the center out. And the equation of the circle, you just plug in then from the formula in the tables. So here's another example now. I'll leave this with you for a minute. How will you solve this one? You're told there are 3 points, and they form a right angle triangle in the circle. How do you solve that one? All you're given are these 3 points. You have to draw the circle. Okay, this is an interesting part of your course. If you look at the theorems in your course, even though you may not think that they're part of here, they can pop up. And one of the theorems states that if you have a triangle, in other words, if you join 3 points of the circle, of the circumference of the circle, pick any 3 points, this one, and this one. Any 3 points will give you a triangle. But if the 3 points you pick actually give you a triangle like this, where this angle here is 90 degrees, if you have a 90-degree angle in a triangle that's made up of the points on their circumference, it's a theorem and it's proof. And it's known that this side here, the hypotenuse, is a diameter. If you take and construct a triangle on the diameter, it will be a 90 degree. So knowing that theorem is the gateway to solving the question. Because if that's a 90 degree, well then this is a diameter. And if this is a diameter, we've just done that. The diameter is the 2 points, find the midpoint, do the circle, and you're finished. So that's how they hide it. And they hid that one in the theorem. There's only a few, and they've all come up, and you can see it. So you must know your theorems as to how that might pop up. Here's the next one. They give you a circle with a rectangle in the middle, where the 4 points on this particular shape form a rectangle. Now, how do you do that, fella? Okay, we've got a circle with a rectangle. Well, if it's a rectangle, we can take the corners of the rectangle and join them together. Or we could do it this way if we wished. But if we did it just with one of them, let's say here, let's call this A, B, C, and just took that triangle. Sorry, I'll do this. I'll take that shape there. Sorry, I should do that differently. Let's take the circle with the rectangle, and we can join the 2 corners of the rectangle, either that line or this line. Now, just taking one of the lines, then the rest of it becomes triangle. So this rectangle can be split in 2 by the diagonal. So that's one triangle, and the other is on the other side. But if you take either one of those, what you'll find is that the corner is a right angle. And if the corner is a right angle and it's a triangle, and they're all on the circle, this must be the diameter. So going back to the construction of the rectangle, points A, B C, D, and E. BAC is a triangle. CDB is a triangle, both of which have their angle in the middle equal to 90. Therefore, BC is the diagonal. If we know the diagonal, we can find the midpoint, find the circle, and we go round the merry loop again. The last topic on the circle relates as much to the circle as it does to lines and tangents, but let's do it in the circle context. Here we've got a point 2, 3, a point 6, 6 on the circle, and we're asked to find the equation of the line that is a tangent to it. So how do we do it? Well, really 2, 3, and 6, 6 are given to us. So if 2, 3, and 6, 6 are given, one can be called x1, y1, and the other can be called x2, y2. And if we have 2 points, there are formulae in the formula tables that would allow us to look them up and to work out the slope or the change in the north direction as we go east for every step. Now it looks like we go from 2, 3 to 6, 3. That'll be 1, 2, 3, 4. That's 4 steps. While we go from 6, 3 to 1, 2, 6, 6, that'll be 3 steps. That being the point here, 6, 3. So 4 and 3 gives us a slope of 3 over 4. So for every 4 steps we go up 3, so it's a 3 and 4 slope. And that's what we call M1, because M1 is, or L1, the slope of the line L1. But we're interested in this other line that's a tangent to it, which is L2. And if things are perpendicular, we're told that if the slope of one line, L1, is 3 over 4, the slope of the other one must be such that M1, M2 is minus 1. Now generally you can say 3 over 4, the other one you flip it and you say 4 over 3 and you put a minus before it. So that gives you minus 12 on the top, 12 on the bottom, or minus 1. If you want to do it slow, what you do is you say M1 is 3 over 4, M1, M2 is minus 1, so 3 over 4 times M2 is minus 1. Let's do it step by step. Let's get rid of the 4, multiply. So I get 3M2 is minus 4. Now let's get rid of the 3. And I say M2 is minus 4 over 3, which is what we got here by flipping it. Now we know at this point that the slope of this line is minus 4 over 3. That's M2. If we look this up and we do some calculations, there's a formula given to us for the equation of a line given the slope, and it says y minus y1 is m times x minus x1. We know the point x1, y1 is on it. We know that 6, 6 is on it. So 6, 6 is there. X and y are variables, but also we know that M2, M in this case, is minus 4 over 3. Minus 4 over 3. We say y minus y1, that's 6, is minus 4 over 3. X minus, now x1, we're careful, that's a 6 as well. So y minus 6 is equal to minus 4 over 3, x minus 6. Not particularly pretty. I'm going to multiply this side by 3, and I think this side by 3 as well. So 3y minus 18 equals, that gets rid of that, minus 4x, minus by minus, plus 24. Taking the x over, I get 3y plus 4x. Taking this over, minus 42 is 0. So 4x plus 3y minus 42 is naught. So that's the equation of the line, and I now have it. And just to feel a little bit reassured, 4x plus 3y minus 42 is naught. 3y, if I left the 3y on this side on its own, would be equal to minus 4x plus 42. Y would be equal to minus 4 over 3, or x, plus 42 over 3. dy dx would be, if y is equal to that, minus 4 over 3, which is m2. So the slope of the line, the m, all of that stuff is there. So the equation of the line then, I got from looking up the formula page. I had the point 66. I knew the m was minus 4 over 3, and I got the equation of the line. And that's the end of circles.